Hello everyone. So now I will actually take this opportunity to give you the theory to simplification, and then with this video I'll also give you some common mistakes that people sometimes will do, and then I'll tell you like how they can actually complicate it in an exam to make your life a bit more difficult, but because you was helped by Caesar, you'll be in a position to actually tackle them better. So I'll just, before I actually go forward with everything, I'll actually try to maybe this time like draw a picture. So this is actually my picture to simplification. Simplification is actually taking things and then collect them in their respective way. So what will you do in simplification? You'll find that maybe you've got x squared plus another x squared, and then maybe plus x. So what we're actually interested in simplification is collecting these things, the x squared and x squared, so that you can get 2x squared. But you can't really add this one, because why can't you add this one? You can't really add bananas to apples. So in simplification, you're not really interested in how many fruits are there, which is actually be 22 in this case, but we're actually interested in the individual numbers. Let's just say I've got 7 bananas, I've got 3 apples, and I've got 12 oranges. So that's what we'll actually be doing in a lot of ways. With simplification, we'll actually be collecting things like with the closest way of which they relate. So I hope this picture will maybe make simplification a bit easier for you. And then the next thing that I'll actually do is to show you how to simplify. So whenever maybe you're given something to simplify, you'll actually be given something in this form. So when something is in this form, it's usually being said to be in its factored form. So you get it in its factored form by actually doing factorization, but we'll actually do it in the future. So you actually say to do something when you simplify. Over here I've actually written it. You actually will multiply this term with this term, which corresponds to this yellow, and this term with this one with actually. So this will be your first step, then this will be your second step, this will be your third step, and this will be your fourth step. So it will be something like this. You'll just multiply this by this, you multiply this by this, and then you multiply this by this. And then after you do all that multiplication, this will be something that results. So when you say x times x, you'll get your x squared. X times 3, you'll get your 3x. 2 times x is equals to 2x, and then 2 times 3 will actually get your 6. So that's what I meant by saying you actually collect the bananas. So these are not different, but these two are actually the same thing. These 3 are just different, but these 2 are the same. So with them being the same, you actually collect the like terms so that you can get these 5. So this thing is now in actually its simplest form. So you've actually simplified it. So that's what you'll actually be doing in most cases when you simplify. So some common mistakes, as you've just seen, we actually took this number, multiplied it here, we took this one, multiplied it here, and then we took it here and multiplied something like that. So but why did we do that? We did that because there was actually some sort of like an implied multiplication here. See, here it is actually implied that you multiply, but here it actually says we need to add them. So do not do that multiplication if it actually asks you to add. What you will actually do when you do that thing, you have to all know mathematically that whenever something is like that, you actually have an invisible one here. So what you'll actually do is take this one, multiply it here. So 1 times x, you'll get your x. 1 times 3, you'll get your 3. And then you collect the like terms. So x is the same as the x. So it's x plus x, you get your 2x. 2 plus 3, you'll get your 5. So this will be your answer if you do. So please do not do that mistake. The next thing. So yeah, I think that will be just it for now. And then what we'll actually do is like how they can actually try to complicate your life. So if you see, I've actually showed you something with 2 brackets. So when it's with 2 brackets, what do you do when you meet 4? Oh well, 2 brackets, you can actually divide this thing to have 2 brackets and to have other 2 brackets, and then you apply the same rules, and then you get the same thing. So here's what I've actually did. You see, I've actually did the same rules, but I actually did it in different terms. So whenever I do this thing and then I collect the like terms, I'll end up with something like this. and then whenever I do this thing, collect with this thing, I end up substituting. So now it gets a bit more complicated, because now we used to have 2 terms, now we have 3, but it doesn't matter. You just do it the very same way that we did it. So now you'll take this one, multiply it here until you're done. You take this one, multiply it here, you're done. So you see, usually we had 2, but now we've got an extra. Now we've got an extra, and now I've got an extra, but we only have an extra because we've got an extra term. Otherwise, simplification will work in the same way. So that's possibly like one of the most complex things they can ever change. So whenever you actually see that they are trying to complicate things for you, you just tell them, I've done this thing somewhere, it's actually easy, and then you get your full marks. So that will conclude our theories, and then I'll move on to the example.